Greetings, my name is 𝗧𝗜𝗠𝗘. I'm the Process Optimization Specialist for Lakeside Process Controls and Emerson Impact Partner. This episode, we're going to cover how to read in files into Analyse. We're going to talk about time shifting the time series and why we want to do that. We're going to talk about generating XY plots, scaling XY plots, and also doing regression analysis on these XY plots as well. So here we got to Analyse, and I'm going to read in a file. So I'm going to read in FIC PV and an output. So I'm just reading the two data sets. You got the standard plot right there. Everything is okay. And I'm going to set up a new view and just to look at them overlay just to see how they look. So I'm going to do an overlay plot. And you can see here, this is over 8 hours worth of data. The red line is the PV, the green line is the output. You can see and take a note here how the output kind of swings back down a little bit later on. So now what we're going to do is set up an XY plot. So new view, and we're going to select XY plot. But here I want to have the X value, the independent variable, the output, and the flow PV is going to be, oops, I got to fix that. Going to be the PV. Essentially here, we're looking at the flow curve. And this is what the flow curves look. So the x-axis is the output, the y-axis is the PV. And you can see here, it's not in the most linear type of flow response. So I got to change it here. Because I always say beware of auto scaling. So the span of the transmitter is 0 to 6,000. And the origin is going to be 0. Apply that. And I'm also going to change the X scale as well. So from I got to go from 0 to 100. And there we go. And you can tell here it's not the most linear, so it's fairly okay until about 40%, then seems to give out the ghost around between 40 and 50%. Now, the other thing also here, you can see this little curve back, and that is an indication. If you look at back here, this, remember I told you to look at this, it's an indication here that there's some hysteresis, some valve hysteresis within the valve itself, and that's what that indicates right there. So it's a good indicator for control valve hysteresis as well. So here we're going to actually see, okay, what kind of sensitivity, what kind of process gain do we have, or process sensitivity we have at different valve opening. And so you do a window the data, and here I'm going to draw a window around a certain area. And then I'm going to look at another area, so right around 40%. Mark that as well. And you know what? I'm going to change window 1. It's not exactly where I want. I want to see where it is more around 20%, 20 to 30%. I'm going to change that. So you can then edit your windows as well. Next thing I'm going to do is fit window data. So there you can see window 1, and I could choose any kind of curves here. I'm going to choose a linear curve and do a calculation fit. Now you can see the slope is 88.8. That means that's a slope 88.8 kilograms per hour per percent. And the standard error is the average error deviations from the model itself. I got to hit apply. Now it's hard to see there, but there's actually a blue line right there. And the red line is the calculation of that slope at 88.8. Now I got to go for slope 2. I got to keep it a linear as well, calculate fit. Now you can see here it's 56, so we went from 88 to 56. I'm going to apply that as well. Now you can see here it shows the slope for the first window, and now it's showing the slope for the second window. You can see here obviously there's a big difference depending on where the valve operates, and this is what the flow curve can tell you. Now I can actually save this information as a workspace, not as a DAT file, but a workspace. And you see that .xy workspace, save it, and now all that information has been saved. Now I got to close this, and it's going to warn me, yeah, you sure you want to close this? They say yes, yes, yes. And I'm going to close this as well. Now I got to read in another data file. I'm going to read in two temperatures that are operating, and I want to see if they're correlated, how well correlated they are. So you can see here, there's a second data set, the first. I can flip back and forth. They're both oscillating. They seem to be time shifted a bit, right? They're out of phase. So I'm going to go here and new view. And so here I can select XY plot. Looks like a mess, looks like a spirograph. So what I'm going to do, I got to go back to set up a new view and look at an overlay plot. And so here you can see the overlay plot. So now what I can do is I can time shift the data. So I do a right click all the way down, time shift data. So I'm going to look at time shifting one of the data sets. So I'll try with one first. Try, let's say 30 seconds. I'm actually shifting the wrong one. So I'm going to undo that. Now I'm going to shift the second variable, time shift. And what you're doing there is you're trying to, in this example, you're trying to shift the data to kind of the two are almost right on top of each other. So it's a good way to eyeball what the time delay is, or in this a phase shift is in this example. 25 seconds seems to be all right. Let me try 22 seconds. And that looks reasonably correlated there. So I'll just undo that for now and just cancel out of that. And I got to go back to the XY plot. And now I'm going to time shift here and go back to time shift the second variable and enter my 22 seconds. And obviously you can see here it looks a bit more correlated. I know we're zoomed in here, and I always say beware of auto scale. So I'm just gonna kind of change the scaling here to give it more of a better perspective. So you go from 45 to say 35 there, and then again there, 35 to 45. So there's definitely is a correlation there. Still a little bit fuzzy, but you can definitely see. So I got to window this plot here. Again, you can see here the window. I'm just encompassing the whole data set. And now I got to do a fit window. Calculate the fit and keep it linear and apply it. You can barely see there is a blue line there. The red line is almost 1.1. So it's almost like a one-to-one correlation in this example. So this is really good at establishing correlations between two different variables. So I got to close this. No, I'm not going to save it. And I got to close all. Now it's going to tell me, oh, you've actually modified one of them here. Do you really want to close it? You modified it, but you haven't saved it. But we're going to just close it for now. It's going to tell you, sure. We'll say yes. Next thing we're going to do is another one's a heat exchanger example. So this is over 1 day of data. And what I'm actually want to correlate here is the inlet temperature to the heat exchanger to the control valve output. So the red line is the inlet temperature, and the green line is the output to the control valve. And obviously, you can see there's some degree of correlation going on there. So what we want to do is establish what is that correlation. So we go back, new view, XY plot. So now the X variable is going to be the inlet temperature and the output. So you can see here again, kind of zoomed in. We're going to zoom out a little bit just to get a bit of a better perspective. So we go 75 to 25. And do the same thing for the X scale as well. So we go from, say, what can we go to? From 0 to 50. All right. So you can see here, it does look linear, but it's actually more of a curve to it, right? So it should be interesting. So here, let's take a look, and we're going to window that data again, just like we did before. I'm going to mark it. And now we're going to fit the data. So here we're going to try a linear, calculate the fit. And there's a slope and standard error of 2.5. It's hard to see, but there's a blue line there, kind of fits. It's okay. You know, it's okay. Maybe we'll just try a different order. What we could do is a second order, do a calc fit there. So the standard error went from 2.5 to 2.46, a little bit of an improvement, and the curve does look a little bit better. And the red line is a slope of that blue curve. So let's just try one more. Let's just try a third order and see how that looks out. No, the standard error went again to 2.46, so not much of an improvement from before the second order, so we should probably keep it simple and keep it maybe second order. So remove that, and I'll go back to second order. So that's how you use the XY plot to actually generate. You can see correlations between the independent variables. For flow valve, flow controls, you can actually see the flow curve of the valve, which is really the most important part. You know, we could talk about CV curves and so forth, but the flow curve is what we're looking for. So next Analyse video, we're going to talk about power spectrum. We're going to talk about the data manager, because it's very easy to be accumulating over 3,000, 10,000 data files. How do you navigate through all of them? How do you sort them? How do you, and so forth. The data manager is very, very important. And then we'll talk about later on about importing data from, let's say, an Excel spreadsheet into Analyse, and vice versa, how to export data from Analyse to a text format, typically an Excel format. So I found you found that interesting, and always drop me a note if you have any more questions. Thank you very much.